Morning, everybody. Sorry I'm not in today. I'll be back tomorrow. So if you have any questions, feel free to come in tomorrow morning and we can get caught up on anything that maybe you had questions on from Friday or from today. But all right, let's go through this warm up. Factor completely, then graph the polynomial. So take a look at what you have. Really don't need this equal sign since we're not solving. But you have four terms, and we know what a zero is. So that means that we could try to factor by grouping, but I'm just going to tell you it's not factorable by grouping. And anytime that you're going to be given a solution, you might as well use it and use synthetic division. So set up your synthetic division. We have a 2, 13, 8, and negative 48. All right, bring down your 2, multiply, add, multiply, and so I get left with the function 2x squared plus 5x minus 12. Alright, it's trinomial, so I should be able to factor. Let's see. 4, so that works. So this gives me 8, 3. Alright, so I have the solution of 3 halves and negative 4. And then I also had the solution of negative 4 to start with, so I'm just going to underline this one. So that's going to matter when I graph it. Okay, so remember, because I have two solutions at negative 4, that means it's going to bounce there. So we'll put negative 4 over here and 1.5 over here. It is a leading coefficient of 2, which is positive, and a 3. So I can't go like this because I'd have to come back up, and then I'm hitting 3 times. So I need to make sure I bounce. So I'm going to bounce at that negative 4, which means that I'm going to hit it, come back down, and then I got to go back up. Okay? Alright, so let's talk about today's stuff. So rational root theorem says, if f of x has integer coefficients, then every rational zero of, I should say f of x, has the following form. So p over q. So if we take the factors of the last term, and your last term is always going to be your constant, and then factors of the leading term, or your first term. Okay, so here's what this allows us to do. Show you an example. So use the rational root theorem to list all, so we're listing, we're not finding, list all the possible rational roots of the polynomial. So here's my last term, that's my p, here's my first term, or my leading term, and that's a 2. Okay, so what this is saying is if we look at the factors of 6, 6 has factors that are 1, 2, 3, and 6. So meaning 1 times 6, 2 times 3, 3 times 2, and 6 times 1. And then my factors of 2 are just 1 and 2. Okay? So this means that I can look at, this is a big fraction, so like if I look at this 1 right here, and I have 1 over 1, that means that one of my possible roots is going to be a plus or minus 1. 1 over, and then I have 1 over 2, so plus or minus 1/2. And then if I skip now to the 2, I have plus or minus 2. And then I also have plus or minus 2 over 2, which is just 1, and I've already listed it here. So look at my 3. That gives me plus or minus 3. And then plus or minus 3/2. My 6 gives me plus or minus 6. And then I get 6 over 2, but that's the same as 3, so I don't need to rewrite it. So these are all my possible roots. That doesn't mean that they all are roots, because I can only have at max 4 anyways, but it gives me an idea of where to go with it, with my function. Okay, so the reason I would want to know this So for this next problem, so we'll show you for the next problem, it says without a calculator find all of the solutions. So this doesn't say list the possible, it says find all of them. Well, I could try to factor this by grouping, but I'm just going to tell you it's not factorable by grouping, so without picking up a calculator, it becomes a little bit hard then to figure out how to factor this. If I picked up a calculator, I could graph it and look and see where it hits the x-axis. But using this rule that we just talked about, number 1, now I can say, okay, well, 5 is my last number, and 1 is my leading coefficient. Well, that tells me if 5 has factors of 1 and 5, and 1 just has factors of 1. So that means that my possible roots are 1 over 1, which is 1, and 5 over 1, which is 5. So those are my 4 possible roots. So I'm just going to test them to see which one works. And then once I use synthetic division, it'll go down to a trinomial. Okay, so I'm going to try positive 1. And I have a 1, a negative 3, a 1, and a 5. Okay, so negative 2, negative 2. Alright, and then that didn't work because I didn't get a remainder of 0. So I'm going to erase this. Oops. Alright, let's try again. Alright, so now I'm going to try making this a negative 1. So bring down my 1 times multiply them, add them, multiply, add, and then look at that, it gives me my 0. So that means that negative 1 was a possible root. And now I'm going to factor. I have x squared minus 4x plus 5. So if I try to factor this, multiple factors of 5 would just be 5 and 1. Notice though that none of those are going to give me a negative 4, which means then that this is not factorable. That doesn't mean that there's not real solutions, but that means now I have to use the quadratic formula. Remember the quadratic formula? Underneath the radical was your b squared minus 4ac. Remember, we can only take the square root of a positive number, not a negative number. So before I use the quadratic formula, I'm going to use this discriminant. I'm going to see if it's even possible to get a 0. So b squared, so my b is negative 4, so squared is 16, minus 4 times my a value times my c value. And this gives me 16 minus 20, which is negative 4. So then that means that there are no real solutions, at least from that quadratic. So that means that the only real solution I have is x equals negative 1. Okay? And that was using synthetic division without me giving you a 0. You had to go find the 0. It's kind of a pain to use, but sometimes you gotta use it. Okay. Next, write the simplest polynomial function with integral coefficients that has the following zeros. Remember, zeros means that they're your factors. So actually, we're going to start with number 4, so it's a little bit easier one. So if I want to have negative 7, I would have to say x plus 7. For positive 3, I'd have to say minus 3. And then the fact that that's a 0 just means that I would put an x on the outside, because I'm not going to say x minus 0. Okay? So now let's go backwards. If the other one, I need to have these two. Now this means that you also have 3 plus I as a solution, because if you remember, if I was taking like the square root of negative 16, I get plus or minus 4i. I always get that plus or minus. So even though this is saying 3 minus I, it also includes 3 plus I. So if I want to write this out, I would say x minus 5 to give me the solution of 5. And then I would say x minus, and I need to subtract 3 minus I. And then I need to say x minus again, but this time I need to subtract 3 plus I. I'm actually just going to leave my answer like that. Okay? So if we try it again over here, my 8 would be x minus 8. This 4 plus I also has a 4 minus 6i. Okay, so I have to do x minus, and then I need to say 4 minus 6i. And then I need to do it again and say x minus, but this time 4 plus 6i. Make sure that you have parentheses around this, because otherwise you'd only be subtracting the 4. And we can just leave our answers like this. We don't want to just subtract the 4. We also want to subtract that minus 6i. Okay? Alright, flip it over. So that's pretty much the only thing that's new for this lesson, and then I threw in some more problems with solving. So you guys know a bunch of ways now how to solve. If it's a trinomial, factor it, find your solutions. If it's groupable, you can factor by grouping. If you're given a solution, then you want to use synthetic division to help you break it down into an easier polynomial to factor. Okay? So, let me go through some with you. Okay, so if I know that this is my solution, I'm going to say -1, and then I'm going to have a -2, a negative 2, 32, 32. Okay? Oops, sorry. You guys don't have this. Sorry, you don't have this. So if we're factoring this, then there's 4 terms. I can see that I can factor out a -2x squared. That leaves me with x to the 3rd plus x squared minus 16x minus 16. From here, I can factor out an x squared and a -16. So that leaves me with x squared, x plus 1 minus 16, x plus 1. They're the same, so I can group them. So I get x squared minus 16 times x plus 1. Don't forget about your -2x squared from here. I can see that this is factorable further. So I have -2x squared, x plus 4, so it's a sum and difference problem, x minus 4, and then x plus 1. Okay? It tells me that I have 4 solutions. One of them is 0, one of them is a 4, and the other one's a -4, so I'm just going to say plus or minus 4, and then my other one is -1. Okay, so that's what I'm trying to do, is just find all of my solutions. Alright, next one. Number 7. Okay, so I see 4 terms, so I'm thinking factoring by grouping. This one, you guys have a solution of -3. So, -3, I have a 1, I have a 4, I have a -3, and I have a -18. Alright, so I bring down my 1, you do my synthetic division. I get -6, I get 18, and that right there tells me that this was a solution. Okay, so I have x squared plus x minus 6. That's a pretty easy trinomial to factor. I have a 3, I have a 2, minus, plus. So x equals 0 is a solution, x equals -3 is a solution, and then this one actually has a double root, we can just say, because remember, this was a solution. So double root. That means if I had to graph it, I would bounce it there. Okay? Let's try another one. Alright, next one. Alright, this one I can factor out a -2x, which leaves you with x to the 3rd minus 5x squared minus 9x and plus 45. So 4 terms, I can factor an x squared out of here and a -9. So hopefully we're seeing quicker one to factor by grouping. I have x squared. I get left with x minus 5, -9, and x minus 5. So they match, so I can group them. This right here, I'm just going to skip a step, is going to give me x plus 3 and x minus 3, because it's sum and difference, with an x minus 5, and with a -2x on the outside. Don't forget that one, so that one's going to give me an answer of 0. I have answers of plus and minus 3, and I also have that x equals 5. Alright, let's try another one. Alright, over here, I have 2 zeros that I'm given. I'm just going to do the -1 first. So I have -1, -4, -2, 24, 46, and 24. Alright, so do your synthetic division. You may want to pause it and try it on your own. Just make sure that you're doing okay. 2, negative 2, 22. Negative 22 here. 24, negative 24. There's my 0. Alright, now I'm going to do it again with 3. So I get 24. Oops, sorry, this was a negative, which means that's a negative. Okay, so that brings me all the way down to negative 4x squared minus 10x minus 8. I'm going to factor out a negative 2, which is going to leave me with 2x squared minus 5x plus 4. Alright, so when I factor, so I'm looking for factors of 4. I know it's got to be minus and a minus. Sorry, that's supposed to be a plus. Okay, so I'm trying to figure out factors that are going to give me a positive 4 and add up to give me a 5. Well, the problem is if I put a 4 here, that's going to be 8. If I put a 1 here, that's 2. No matter what, I'm not going to get anything. So I might have to use the quadratic formula. So I look. Let's check and see if maybe I even have to use the quadratic formula. So I'm going to use that b squared minus 4ac again. So that's the discriminant. So my b squared would be 25 minus 4 times a times my c value, not c. Okay, so remember, the reason I'm doing this is because I don't want to use the quadratic formula if I don't have to. I'm checking to see if there are even real solutions. Well, this gives me 25 minus 1632. So this is a negative 7, which means there are no real solutions, because I'd be taking the square root of a negative 7. That means my only solutions are the ones that I was actually given to start with, just those two. Okay? Next. Alright, let's see. I have 4 terms, so I'm going to look to factor by grouping since I don't have any of my my x's. Alright, so I can take an x to the third out of here. I can take a negative 27 out there. I get x to the third, x squared minus 1, minus 27, and I get x squared minus 1, so that's good, they match. So x to the third minus 27 times x squared minus 1. Okay, now I could factor this further. This is a sum and difference problem. And then this right here is that cubic that we talked about. But remember, I'm solving, so I really don't need to factor it any further. It would actually make it more complicated. For instance, if I solve this, I really don't want to list out all that stuff, because if I solve it, it's only going to take me 2 steps here. I add 27, and then I take the cube root of this, or I can raise it to the 1/3. But the cube root just means I'm saying what times itself 3 times is 27. Well, that's 3, because 3 times 3 times 3. Okay, so if I do give you these types of problems, I'll make it pretty reasonable. And if not, since you guys can't use a calculator, then just leave it like the cube root of something. Okay, if that was like 28. And then my other answers are, I'm over here, I'm going to add 1 to both sides and take the square root. So, this is what I mean. And when I take the square root of that, that's going to give me 2 answers, plus or minus 1. So I have 3 answers there. Okay? Alright, last one. Alright, at this point you might want to pause this depending on how your time is going and see if maybe you can do this on your own before watching me do it. Okay? Alright, so maybe right now we're checking answers. Let's see how you guys did. First of all, I need to set this equal to 0, so I need to move the 8x squared to the other side. So we have 6x to the third minus 8x squared. I'm going to put it in descending order. Plus 15x minus 20. These two and these two I'm going to group. So I can take 2x squared. And over here I can divide by 5. Okay, so 2x squared is going to leave me with a 3x minus 4. Over here, if I take a 5 out, I get left with x minus 4 as well. Oops, sorry, 3x minus 4. Alright, so 2x squared plus 5, and then times 3x minus 4. So I want to solve this. 2x squared plus 5, well, if I was solving, so if I'm setting that equal to 0, might help to actually write this out. So we need a couple steps here. I'm going to subtract 5 from both sides, and then I'm going to divide by 2. But here's the thing, when I take the square root, I'd be taking the square root of a negative number, so that's not going to give me a real solution, so that means this doesn't give me anything, which means I only have one solution. My solution would be 4/3 from this one. Add 4 divided by 3. Alright, so only one solution. Alright, so let's take a look at your homework real quick. Alright, so here's your homework. You're going to do writing in simplest form so that you can look back at your notes. It's the same thing. In number 3 here, without a calculator, find all of the solutions of the function. You're not going to be able to group this. You're going to have to go through and use your last term and your first term to list out your possible solutions, and then just use synthetic division and check and test them and see which one works, just like we did in our notes. Okay? Just like this one in our notes, where we had to go through and we had used synthetic division and then it didn't work. So then we had to try it again with a different one. Okay? Alright, and then you're going to do 2 problems where you factor completely so that you can graph a sketch of the function. So make sure you write out the function when it's factored. And then in all these, you're going to solve. So you're going to go back and forth between using synthetic division and then factoring by grouping, blah, 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 blah. All those methods that you can use now to solve an equation or solve a polynomial. Okay, just be careful with this. This is not saying that 0 is a solution. It's saying equals 0. I know when I was going through making the key, I kept wanting to do that. This is your 0, that 1 right there. Okay, I did it over here too. That 3 is your solution, so use that for synthetic division, not the 0. Okay? Alright, if you have any questions, come in tomorrow morning. I'll be back tomorrow. Alright, I hope you guys have a good rest of your day.